Good day, everyone. We'll be presenting a paper titled A Novel Generalized Form of Cure Rate Model for an Infectious Disease with Co-infection. The co-authors for this work are Sunday Adewale Olale, Zelzi Gao, Becca Taivone, and myself, Oluwafemi Samson Balogun. The co-authors are from School of Computing, University of Eastern Finland, Department of Marketing, Management and International Business, University of Oulu, Finland. We'll be guided by this outline: introduction, research, aim and objective, literature review, methodology, results, contribution, implication and conclusion. Introduction. Survival analysis applied in many areas of study, including epidemiology, public health, medicine, and biology. The survival data is used to show time to event data modeling, which may be applicable to being alive or time until death, as the case may be. The survival time or failure time defines as time to event of interest, Zhao 2008. Research and development in medical science world is currently enhancing the life cycle of patients with a wide variety of diseases, including deadly diseases such as cancer, tuberculosis, and HIV/AIDS. The progression of research in the area of cure motivates this research, which is paramount in any epidemiological research, coupled with less research that focus on the area of an infectious disease with possible co-infection. Research aim and objective. The primary aim of this research is to extend and improve a broad-based model, a non-mixed model for infectious disease based on the BCH model to estimate the performance of the management. The objective of this work is to derive an appropriate probability density function for sole infectious and co-infectious disease and estimate the cure rate parameter for the two situations, the sole infectious and the co-infected patients, using a simulated data to enhance the practicability of cure model and elucidate the same to the non-statistician like public health researcher, psychiatrist, educationist, criminologist, and reliability engineers. The literature review. This section reviews relevant literature based on research done on an infectious disease and application of cure rate model. Methodology. This study uses simulation. The study employed R software to generate the data used for this work, to estimate the proportion of the cured, uncured, the variance, the bias for the sole and infectious patients. The results. The survival times is generated using an inbuilt function in R package for exponential and Weibull distribution model. The sample are set to 500 and 1000 for the two distributions, and different values were used for the censoring rate. The parameters in the two models were estimated before maximizing the log likelihood function for both models. The simulation was done using R package. The two table you can see there shows the sample used, and the cure and the uncured calculated, bias and the variance. As you can see, if you look at the sample generated with 500, the exponential gives 23 for the cured, and the uncured had 77. So also the bias is giving us 0.0057, and the variance is 0.004. Looking at the Weibull, for 500 we have 60, 40, and 0.0057, and the variance to be 0.1661. Now what you could dictate from this is, using 500 and 1000, Weibull parameter does well than the exponential. So also for the co-infected patient, the simulations also, we use 500 and 1000. We could see also that the Weibull does better than the exponential. Discussion. The objective is to derive the appropriate probability density function for sole infectious and co-infection disease, and estimate the cure parameter for the two situations, which is the sole and the co-infectious, using simulated data. Two parametric models were used as a baseline distribution, namely exponential and two-parameter Weibull distribution, for the proposed model to achieve this goal. The simulation suggests that the proposed model performed well in terms of the bias and the cure rate. Hence, this study has shown the consistency of the model. As the sample size to infinity, the variance is 0, that is, it decreases. So also the bias is very close to 0. This indicates the model is non-biased. Using the sample size of 500 and 1000, we were able to estimate the bias, the variance, and the fraction of the patient which is cured and uncured. And this result is given in table 1 and 2 for sole infectious and co-infected patients, using the two distribution, which are exponential distribution and two-parameter Weibull distribution. Also, the study noticed from the simulation that the bias shows that exponential distribution was a function of the sample, whereas the two-parameter Weibull was not. Contribution. The study shows how simulated dataset can be used to determine if a model performed well or not. In the study, we were able to come up with a novel model which can efficiently evaluate and examine an infectious disease with possible co-infection. The managerial implication. This study will allow health managers and researchers working on co-infection infectious disease to build model using other parametric models as a basis for their distribution. And in terms of the methodology, this analysis will also allow managers to know how to make the right choices when faced with particular analytic approach. Conclusion. This research is restricted to the use of simulation for the dataset and the use of two parametric models, exponential and two-parameter Weibull model. The simulation suggests that the proposed model performed well in terms of the bias and the cure rate. The research also shows the appropriate probability density function for the sole infectious and co-infectious disease, and also estimates the cure rate parameters for the two situations using simulation data. Also, we were able to extend the model to give a generalized form of curate model that can accommodate an infectious disease with possible co-infection by deriving the appropriate probability density function. And also the result was compared with the distribution used in the literature. We could see that in the literature, exponential distribution was used, but in ours, we were able to add two-parameter Weibull. And looking at the result from our study, we're able to show that two-parameter Weibull is better than the exponential. Also, this paper will serve as a wake-up call to the government health-related agencies on the existence of some infectious disease and its co-infections, and the dangers associated with late diagnosis. Future research will be to apply more parametric model on a real-life data. Thank you. We'll be looking forward to your questions.